All right, our next machine is called a wheel and axle. A wheel and axle is essentially a lever that can go all the way around. The formula is almost the same. There's only two possible configurations for it. Either you've got a large effort radius and a small load radius, or you've got a small effort radius and a large load radius. Those are the only two possible configurations. Even something as simple as a screwdriver. You put an effort force on the large radius, the fat end of the screwdriver, to turn something with a much smaller radius, and that's how you gain mechanical advantage, just like with a lever. The law of the lever, load torque equals effort torque. That's the same diagram as before, except instead of distances, notice now we have radii. Load radius, effort radius. Our AMA formula is the same because, like last time, it says it's the same for all machines. And now our IMA formula is effort radius over load radius instead of effort distance over load distance. All it's left to do is some examples. This should be a real quick one. A hand winch has a handle of radius 7 inches and a spindle of radius 2 inches. What is the mechanical advantage? Notice it doesn't say find the IMA or the AMA, just says find the mechanical advantage. So then you just use what you have. So we have distances. We have a load radius and an effort radius. So that's going to lead me to use the IMA formula, which is effort radius over load radius. The effort radius is your 7 inches, load radius is 2 inches, and it gives me a mechanical advantage of 3.5. That's all there is to it. Part B, if it's pulling a load force of 1,500 pounds, find the effort force. All right, so the formula is load force, 1,500 pounds, times the load radius, which is 2 inches, equals the effort force times the effort radius, which was 7 inches. Type in 1,500 times 2 divided by 7, and that's going to give me a effort force that's still quite high, about 430 pounds if I round it for the right number of significant digits. That's about as hard as the wheel and axle gets. Sometimes it's hard to identify which one's the effort radius and which one's the load radius, and just, send me a message if you have any trouble with that. Next one says a force of 12 newtons is applied to a shutoff valve and it transmits a force of 54 newtons to the valve. So the tap is where your hand goes. So that's the 12 newtons. This is your effort force. And then the valve is where your load force is down here. The valve has a radius of 1.2 centimeters, determine the radius of the tap. So that's going to be the effort radius that we're solving for. So we just go 54 newtons times the load radius, which is 1.2 centimeters, is equal to 12 newtons of effort force times the effort radius. Just got to go 54 times 1.2 divided by 12, and it's equal to 5.4 centimeters. That's all there is to that. It also says find the mechanical advantage. Again, we're not given whether or not to find the IMA or the AMA. I'm going to choose to find the actual mechanical advantage this time, only because we're initially given the forces and we had to calculate the 5.4. We could have screwed it up. I don't think that we did, but you never know. 54 divided by 12 is 4.5. The units cancel out, and that is the answer. That is how you deal with a wheel and axle. In summary, if the load radius is smaller than the effort radius, it causes, well, it's going to look like that. Here's what I want. It makes lifting easier, like a doorknob does, like a screwdriver does, like a steering wheel does, but it is slower. If the effort radius is smaller than the load radius, like in that situation right there, then it moves the load faster, but it's more difficult, like a pull start motor, like a flywheel, like a top. So it moves the load faster, but it is harder. That just means more effort force required to do the moving of it. So that was just a short one. Hopefully you can see that the wheel and axle works almost identical to the lever, except it spins round and round instead of just going up and down. The math is the same. If you understand how to use this formula, you'll see that most of these are just the same. All right, that's it for this one.